All right, let's dive into a topic that, probably keeps a lot of us up at night. Secrets management. I mean, in a world where our apps are sprawled across AWS, Azure, GCP, the whole shebang, how in the world do we keep our passwords, tokens, and API keys from getting into the wrong hands? Well, we're going to figure that out.
So let me just start by asking a question that might make you squirm a little bit. If you took a hard look at your code base, your config files, maybe even your Slack history, are you absolutely 100% positive there isn't a stray API key just hiding out in plain sight? It's a pretty common fear, and honestly, it's because it's a really, really common problem.
And right here, this is the heart of the issue. It's the practice of hard-coding credentials, just sticking static, never-changing keys right into the source code. It feels so quick and easy at the moment, right? But in this crazy multi-cloud world we live in, it is without a doubt one of the biggest silent risks you can take. A single leaked key can lead to a massive, massive breach. Okay, so let's really put a name to this thing. We're going to unpack your pipeline's secret problem, and it all boils down to the absolute chaos of trying to manage all these different credentials. And this is where it just gets so messy. We're not talking about protecting one password. Think about it. Your pipeline probably needs AWS keys for S3, then an Azure Service Principal to deploy an app, a GCP service account for BigQuery, a GitHub token to pull the latest code. Oh, and of course, database passwords. Trying to juggle all of those separately, it's just a recipe for disaster. But there is a much better way. So let's pivot away from the problem and start talking about the solution. What we're aiming for is a unified management strategy, something that takes us from that state of total chaos to one of complete control.
So what's our North Star here? What's the dream? Well, it's a system that is centralized, dynamic, and automated. That means one single place to manage and audit every secret. It means credentials that are created on the fly and don't live forever. And it means a process that pretty much takes human error out of the equation. This is what the pros do to secure a modern pipeline.
So how do we actually get there? It's not as complicated as it sounds. We can break this whole strategy down into 3 core pillars of security. Think of these as the fundamental best practices, the foundation for a really solid unified secrets management system. And here they are. First up, we've got secret scopes, which is all about the principle of least privilege. Second, using short-lived credentials to just shrink your risk. And third, secret scanning, which is our essential fail-safe. We're going to walk through each one of these. Okay, pillar 1, secret scoping. This is all about what we call the principle of least privilege. Here's a great way to think about it. It's like a valet key for your car. You don't give the valet a key that can open the trunk and the glove box, right? No way. You give him a key that can only start the engine and park the car. It's the exact same idea for our pipeline. It only gets the permissions it absolutely needs for one specific job and nothing more.
This slide just nails the difference between the old way and the new way. Static keys are that one key opens all the doors approach. They last forever, and if one leaks, an attacker basically has the keys to the kingdom. Dynamic credentials, on the other hand, they're about giving out the right key for the right door. They last for just minutes, maybe even seconds. So even if one somehow leaked, it'd be useless almost immediately. The risk is just so much lower.
And here's how those short-lived credentials actually work in practice. The lifecycle is honestly beautiful in its simplicity. The pipeline starts a job and requests access. A central vault generates a totally unique, super scoped credential just for that job. The pipeline uses it, and the second the task is done, that credential is automatically revoked. Poof, gone. The window of opportunity for an attacker shrinks from like years down to a matter of seconds. Okay, but what if a developer just makes a mistake? What if they try to commit a secret anyway? We're all human. Well, that's where pillar 3 comes in. Secret scanning. This is your automated safety net. It's constantly watching for those little human errors that even the best processes can't prevent. It's the failsafe that catches what everyone else might miss. All right, enough theory. Let's make this real. We're going to walk through what a secure pipeline looks like in action, so you can see exactly how these 3 pillars click together to build a truly secure CI/CD process. It all starts right where the code is born, on the developer's machine. Before code even gets committed, an automated scanner zips through it looking for secrets. If it finds an AWS key or a password, bam, the commit is blocked. The vulnerability is stopped before it even gets a chance to exist. That's pillar 3, secret scanning, acting as our very first line of defense. So, the code is clean, it gets pushed, and the pipeline job kicks off. Now, you might be wondering, how does the pipeline get its first secret without, another secret? It doesn't need one. The pipeline itself has a secure machine identity. You can think of it like a digital fingerprint. that lets it prove who it is and authenticate directly with Essential Secrets Vault. There is no master password to get the whole thing started. Now this is the magic moment. Once the pipeline is authenticated, the vault acts like a super smart broker. It looks at the job and thinks, okay, this job needs to deploy to Azure and read a file from AWS S3. Then it generates brand new, temporary credentials with only those permissions, valid for just a few minutes. See? That's Pillar 1 and Pillar 2 working together perfectly. And finally, the pipeline takes those temporary credentials and gets to work. It deploys the services, finishes its tasks, and, this is the most important part, the very instant it's done, the vault automatically revokes those credentials. They just cease to exist. There are no long-lived keys left lying around waiting to be stolen. The loop is closed. If you remember just one thing from all of this, let it be this idea right here. Secrets are not meant to last forever. They should be treated just like ice cream on a hot day. You hand them out for one specific purpose, and you fully expect them to disappear very, very quickly. It's such a simple way to think about a really powerful security concept. And that really brings us to our final thought. Moving to a system with dynamic, short-lived credentials is a huge leap forward. It forces your credentials to expire. So the question I really want to leave you with is this. If you adopt this mindset, this idea of ephemerally across your entire development lifecycle, can you make your vulnerabilities expire too?